Hey guys, welcome to semester 2 today. Sorry I was not at school today on Monday. I had knee surgery on Saturday. I should be back tomorrow. Might be on crutches, but I should be back tomorrow on Tuesday, so we'll see you then. But we need to get started on our Chapter 9 notes. So, Chapter 9, Section 1 is on equations of circles. And here's a little example. Russell is an engineering student using a computer-aided design, which they call a CAD program. You'll hear that a lot in architecture. They use a CAD program. You can input the center and radius of a rotor that he's working on, and the computer can automatically determine the equation of the circle that represents the rotor. Now what you guys are supposed to do on these notes is as I unclick these boxes, you should be filling in with the words that are underneath. Put them in the boxes on your notes. You can print them off my website and just have them as printed copies, or you can copy the whole thing down. I would suggest making a printed copy of it and then writing in, filling in the boxes. It'll be a lot easier. The standard equation of a circle is this: x minus h squared plus y minus k squared equals r squared, where the h and the k, see how the h and the k are red, the h and the k represent the center of our circle. So this is where the center is located, and then r, of course, is going to be for the radius of our circle. It's just a standard equation. It's like having our standard linear equation, y equals mx plus b. Here's a standard equation of a circle, and it almost looks like the distance formula. If you look at it up here, it almost looks like the distance formula. You can use the distance formula to find the equation of any circle that has a center of hk, which you could see the red here, h and k are the center, and has a radius of r. So you can use the distance formula to figure it out. Here is the distance formula with xy as a point on the circle and hk as the center. So if I was going to find the distance between these 2 points, a point on the circle and a point in the center of the circle, that would give me the radius, because it's from the center to the edge. The center is here and the edge of the circle is here. So I would start with my radius, my distance formula. The radius would equal the big square root, the distance between the center point h and k and the point on the circle x and y. What I would do next is I would square both sides of this equation. I would square both sides, and you're going to end up with the square and the square root would cancel out. So you would have r squared on this side, and then you'd have this, which, if you notice, is our equation of the circle. So that's how they got it. To get the equation of a circle, they just use the distance formula between the center point and any point on the circle, and you'll have the radius, which is our equation here. You can pause it at any time and move on. All right, what would be the equation of a circle that has a center of 3, 4, and a radius of 5? All right, well, here's our equation of a circle. So you're just going to write this all in this box. Here's our radius. Just copied it from the previous slide. We're going to plug in the points that we know. The center point is 3 and 4, and the radius is 5. We are going to simplify. The 5 squared is 25, and you just bring this down and you have your equation. You could put this 25 at the end, or you could put the 25 at the beginning. It doesn't matter. Either way, your equation's right. So I was just showing you both ways there. Now, how would the equation be different if the center was not positive 3, but what if it was negative 3, 4? Instead of positive 3, 4, what if the center was a negative 3, 4? And again, pause it if you need to catch up on anything, and then start it up again. Well, if you would plug in a negative 3 here, so it would be x minus the negative 3. Instead of x minus 3, because the h was 3, it's going to be x minus the negative 3, which is actually going to change that to x plus 3. And then y minus 4 is going to stay the same. And again, you could also, underneath that, put 25 equals this. So and that would be the same thing. This 5 squared right here is actually 25. So that would be your equation right here. Okay, write an inequality for a circle that would represent all the points on or outside the circle. Well, any point on the circle would have this equation equaling, this line right here is equaling the radius. So if we had plugged any x and y and it was equal to the radius squared, then it would be on the circle, because that would be equaling our radius. If you square rooted both sides, the distance formula would make it equal the radius. If it's greater than the radius, let's say we plug in an x and y and we do all our math here and it comes out greater than r squared, then it's going to be outside because it's greater away than the radius. It's farther away than the radius. If this was less than or equal to, then it would be inside the radius. It would be smaller than the radius, so it would be inside the circle. So you can always plug in other points and see exactly where they're located in relationship to the circle. You can see if they're inside or outside. For the circle in example 1, find the coordinates of the points on the circle when x equals 3. Okay, so when x equals 3, well, we know the center from example 1 was 3, 4. That's right here, so draw a point there. We know the radius was 5, so we're going to draw a circle that has a radius of 5. So I went 5 this way, 5 this way, 5 this way, 5 this way. Try to draw in your circle. If you have a compass, then use your compass, put it on here, 5, and draw the circle in. Now plug in 3 in the equation and solve for y. Plug 3 into the equation and solve for y. Okay, so my equation from before was 5 squared equals x minus 3 squared, y minus 4 squared. I'm going to take out the 3 and I'm going to put in or take out the x and put in a 3 here. So that's actually going to be 0 squared, which we know is 0. So that's pretty much gone. This is just coming down. And then I simplified that. Now to get rid of this little square right here, we need to square root both sides. So you would want to square root here, and you would want to square root there, which is hard to do with a mouse. But we want to square root both sides. So that's what you'd be doing. And then you would get a plus or minus 5, and then you just have the y minus 4. And if you added 4 to both sides, 4 plus 5 is 9. And 4 minus 5 is negative 1. That means that at 9 and negative 1 is where the circle would touch when x equals 3. When x equals 3, it's going to either touch at 9 or it's going to touch at negative 1. So that is example 2 there. The two coordinates would be 3, negative 1, over 3, down 1, and 3, 9, over 3 and up 9. Those would be the two coordinates. Again, pause at any time. Example 3, you want a laser to put a circle in the middle of a square metal plate. So here's your metal plate, and you want the circle to be right in the center of it. If you want the diameter of the circle to be 40, 40-inch diameter means it's a 20-inch radius. Half of that diameter is the radius. And the square metal plate has sides that are 100 inches. Okay, so from 0 to 100, from 100 to 100, 0 to 100, and so on. Then what will the equation of the circle be? Well, first let's graph the circle. We know that it's going to be in the exact center of this plate, and we know it has to have a radius of 20 because the diameter is 40. That tells me that my center point is halfway over and halfway up. So 50 and 50 would be my center point. 50, 50 as the center, and 20 as the radius, which is half of 40. So we need to plug that into our equation. Radius squared, r squared, equals x minus h squared plus y minus k squared. That's going to equal r squared is, and then we're just going to simplify this. 20 squared is just going to be 400. So we're going to leave all this stuff the same, and we're just going to simplify the 400. So the equation that this circle would be, and the reason this is important is because you would just plug this equation into a computer program, and the computer program would tell the machine to cut this circle right in the center of this metal plate. And so that's why that's important to know the equations of these circles. So at what point would the laser be the closest to the bottom of the plate? Well, at what point would that be? That point right there would be the point 50, 30, because it's halfway over and it's a radius of 20. So it's got to be 20 down from the 50 in the middle. So it's 20 down from 50 would be 30. So 50, 30 would be the point in the center, or the point closest to the bottom, I mean. All right, moving on. Example 4. A circle has a center of negative 2, 6 and contains this point. So the radius would be between those two. There's a center and there's an edge. We want to find the equation. So first thing we've got to do is find the radius. So that's first. First find the radius. So r equals, and we're going to use our distance formula. The radius would be the distance between these 2 points. So I'm going to plug in my distance formula. You're going to come out to be r equals 5. So that's what you're going to get for your radius. The radius of this circle. Now we now know the center and we now know the radius. So let's plug in the radius. So we got the 5, the radius. The center is negative 2 and 6. So x minus negative 2 plus y minus 6. And now you just simplify everything. And you have it. 25 is our simplified there. This is going to come out to x plus 2 squared. And this is going to be y minus 6 squared. This is the equation of a circle that has this center point and it has this as one of our points. If we plugged in a 1 here and we plugged in a 2 there, you would end up with 25 when you simplify this. You get 25. Where would this circle cross the y-axis? If I graphed this circle, where would it touch the y-axis? Well, let's see. We would plug in a 0 for x because the y-axis means that x had to have been 0. So we're going to just plug in a 0, take the equation that we had right here and plug in a 0 for x and simplify it. It's going to be 4 squared. You're going to get 20. You're going to subtract 4 on both sides and get 21. Then you're going to square root both sides and you're going to get plus or minus radical 21. And this should not be there anymore. And then plus or minus radical 21. And then you're going to get 1.4 and 10.6 when you add 50 to both sides. So the circle would cross at 0, 1.4 is one of the places it would touch. And it would also touch at 0, 10.6. So when you graph that circle, it would cross the y-axis at those 2 points. And again, you can pause it if you need to. All right, a couple of vocabulary terms. There's what we call a concentric circle, which is a circle with the same center point. Circle with the same center. Now they might be different sizes. One might be inside the other or one might be outside, but it's going to have the same center point. Congruent circles just have to have the same radius. They may be far apart from each other, but if they have the same radius, they're going to be exactly the same circle. You could put one on top of the other and you wouldn't see the one on the bottom. That's a congruent circle. All right, here's an example. The equation of our circle is this. That means that h, the center point, is 2 and 3, because h and k represents our center point. So the center point is going to be 2, 3, and it equals 45. A coplanar circle has its center at 1, 4, and it contains the point negative 5, 7. So if I found the distance between the center point and the edge point, I would get the radius of this new circle. So it's a coplanar circle. It's a new circle. This was our original circle. Here's the new circle. They want to know, are they concentric? Are they congruent? And why or why not? Well, the center of our circle is the point 2, 3, which is different from the coplanar circle, has a center of 1, 4. They have to have the same center point to be concentric. Therefore, they are not concentric because they do not have the same center. The first one's 2, 3. Second one is 1, 4. So definitely not concentric. The circles will be congruent only if they have the same radius. Well, the radius of our circle is radical 45 because this r squared would be our equation. So if you square rooted this would be radical 45 would be our radius. The radius of the coplanar circle can be found using the distance formula between the center and the edge point. So between the center point and the point on the circle. So here's our radius formula. It's going to be between the center point h and k and the point on the edge x and y. So plug those in. Plug in the negative 5 minus 1 and the 7 minus 4. And then solve them. You're going to get 36 and you're going to get 9. and you're going to get radical 45. And radical 45 is the same as our radius. So the two radii are exactly the same. Circles that have the same radius are called congruent circles. Therefore, the radius is the same. We have congruent circles. All right, the practice problems are here for you guys to do. We are going to go over these on Tuesday, and they should be done. Have these done. If you don't have these done, you're not going to be able to participate in the activity. So have these done. You should be able to do it with the notes that you just took. All right, we'll see you guys tomorrow.